All right, so we're doing practice 16A, and we're going to do number 4 because number 4 is a little bit different. So the first thing we're going to do is we're going to write our given and our find just like we always do in physics. So I'm going to read the problem. It says a negative charge. So the first thing I'm going to do is write down Q1 is negative 6.0 times 10 to the negative 6 coulombs. Exerts an attractive force on a second charge. So this force is a force of attraction. So a force of attraction means that the force, remember, unlike charges, attract each other. So if it's a force of attraction, it's going to be negative 65 newtons. Because remember that if I have a positive and a negative, it's a negative, and that's a force of attraction. But if I have a positive and positive, I have a positive, and that's repulsion. Okay? And then it says on a second charge, 0.50 away, so 0.05 meters. What is the magnitude of the second charge? So I'm going to find Q2. So remember, the word magnitude just means how much. So whether or not I get Q to be positive or negative, in this particular problem, they're not concerned with. They just want to know what's the magnitude, how much is the charge. Okay? So the first thing I'm going to do is I'm going to write down my basic equation. Coulomb's law said F is equal to K Q1 Q2 over R squared. Now, we always are going to rearrange the equation to solve for the unknown in terms of the known. So we want to find Q2. So it's in the numerator on one side of the equal sign all by itself. So right now it's in the numerator, but it's not by itself. So what I need to do is I need to get it by itself. So first I'm going to multiply both sides by R squared. So I have FR squared is equal to K Q1 Q2. And now I want to solve for Q2. So I'm going to divide by this. So I'm going to have FR squared divided by K Q1 is equal to Q2. Why do I rearrange my equation for the unknown in terms of the known? Because in physics, I have a foolproof way to check my work every time. Because when I carry my units through and cancel them, it's a foolproof way to check my work. Now I'm going to substitute in my values. So Q2 is equal to 65 newtons times 0.05 meters squared divided by my constant, which is 9 times 10 to the 9 Newton meter squared per coulomb squared, which is on your equation sheet, times negative 6.0 times 10 to the negative 6 coulombs. So those are my values. Now before I start plugging numbers in my calculator, I'm going to carry my units through to check my work. So when I do this, in my numerator, I have Newton meter squared. That's this and this. In the denominator, I have Newton meter squared per coulomb squared, and then I have a coulomb. So now I'm going to start canceling. So this Newton cancels with this meter squared cancels with this cancels with that. So I end up with 1 over a coulomb. And remember, when you're actually canceling units on your own, you're not going to be writing it like this. You'll just do it on your paper in the equation. So 1 divided by 1 over a coulomb is the same times 1 times a coulomb over 1. So my final unit comes out to be coulomb, which is the correct for charge. And when I do the math, Q2 is equal to 3.0 times 10 to the negative 6 coulombs. And that's my final answer. Now this problem I chose because this was the only one I had to rearrange the equation. Your other 5 or whatever homework problems, those you have your basic equation F and you're solving for F. Okay, so you're not really doing any algebra. So remember, if you rearrange the equation to solve for the unknown in terms of the known and carry your units through, you have a foolproof way to check your work to make sure you didn't make an algebra mistake. That's it.